Hey guys, welcome to the new video on 8086 microprocessor. As you can see in this video, I'm going to talk about the various addressing modes that are available in our 8086 microprocessor. This is a very important topic that we should understand properly in order to write any assembly language program in our 8086 microprocessor. In this video, I am going to tell you a trick that will help you to remember all the addressing modes easily. So I request you to watch till the last in order to understand each and every concepts properly. So without waiting, let's get started. So let's first see what do we mean by addressing modes. Addressing modes refers to the way in which our operands of an instruction is specified. Let's take an example to understand what that means. Suppose we have move AL, BL. Now this AL, BL is our operands and this entire move AL, BL is our instruction. So this operands in our instructions can be specified in various ways. This is one way. Another way can be move AX, in brackets we have SI. Another way can be move DX, in brackets we have BX plus SI. Similarly, another way can be move DX, 1000H. So what we can observe from here is all these operands can be specified in various number of ways. And all these ways refers to the various addressing modes that we have in our 8086 microprocessor. So we will see what are the categories of addressing modes that we have. One trick that I'm going to say is in various books, these addressing modes have different names. So one thing you should keep in mind is you should always remember the keywords. Now what I mean by the keywords, you will understand if you see the next slides. So the addressing modes for 8086 can be broadly classified into two categories. First one is the addressing modes for branch and the second is the addressing modes for data. Now what we mean by branch and data, that we will see in the next slides. So before starting to know about our addressing modes, we should revisit a few concepts that we have discussed in our previous videos. If you have not seen the videos, you can refer to my channel. I will provide the link in description. So the first thing I want to say is, we know every instruction has a physical address in the memory. Now this physical address has two parts. One is the segment address and the other is the offset address. Now the segment address is the starting address of our segment in the memory, and the offset address is the address within the segment. I have explained these topics in detail in my previous videos, so I will just be touching on these topics in this video. Now the offset address has three elements. First is the displacement, second is the base, and the third is the index. So what is displacement? Displacement is basically a 8-bit or a 16-bit immediate value, that is a constant hexadecimal value. We will see that in detail in the next slides. Base means all the contents of our base registers, that is BX and BP. So we know we have two base registers in our microprocessor, which are BX and BP register. And all the contents of the index registers, which are SI or DI, are specified by this index element in our offset address. So our offset address can be formed by the combination of any of these three elements. It can be only displacement, it can be only base, it can be only index, or it can be the combination of both or the combination of all of them. So let's see them in detail. So let's start with our addressing modes. The first one is the immediate addressing mode. Now here the keyword is our immediate. This is our keyword that we should remember. Now what do you mean by immediate addressing mode? In this type of addressing mode, the source operand is a 8-bit or 16-bit data. Let's take an example. Suppose we have the instruction move AX, 1200H. So as we know from our previous videos, this AX is called the destination and this 1200H is called our source. So from the definition we can see our source operand, which is this one, is a 8-bit or a 16-bit data. So in case of immediate addressing mode, our source operand, which is this one, should be a 8-bit or a 16-bit data. In this case, we have a 16-bit data. Let's take another example. Suppose we have move BL, 12H. So in this case, we can see this 12H is our source and BL is our destination. So this source operand is a 8-bit data in this case. So this two hexadecimal values are called the immediate, and thus we get the name immediate addressing mode. Now the main point to note here is the destination can never be an immediate data. That is, the destination that we can see here, which is AX in our first example and BL in our second example, can never be constant hexadecimal values, because destination is a place where our values will get stored. So this destination should never be an immediate data. So again, I'm telling the main keyword here to note is this immediate. This is our keyword. So in this case, immediate is our keyword. Very important. The next is our register addressing mode. So let's see what that means. In this type of addressing mode, both the operands are registers. For example, if we have the instruction move AX, BX, in this instruction we can see for the destination as well as for the source we have registers. So as we know, AX and BX are registers in our 8086 microprocessor. Thus we can see in our instruction only the names of the registers are used as operands. This type of addressing mode is called register addressing mode. Let's take up another example. Suppose we have move BL, AL. So here also we can see these are our registers. This BL and AL are our registers, and thus it has the name register addressing mode. So in this case, the keyword we get is register. So register is our keyword. We should remember this. So whenever we see register here, we should know there should be a register in our operands. The third is our direct addressing mode. So what do we mean by direct addressing mode? So in this type of addressing mode, the address of the operand is directly specified in the instruction. Let's see an example. Suppose we have move CL, in brackets we have 1200H. So this 1200H written in brackets is not our data, it is our offset address. Suppose this is our memory, and in the memory there is a location with a segment address of 5000 and the offset address of 1200, and we know the physical address of any location in the memory is calculated as segment address into 10H plus offset address. So in this memory we can calculate the actual physical address of the location by multiplying 5000 with 10H plus adding the offset address, which is 1200H. So what this instruction does is, suppose we have a value 05H inside this offset address. So this instruction will take the value 05H and put it inside our CL register. So to summarize, inside brackets whatever value we have is an offset address, and this offset address is written directly inside our instruction in order to access any element which was 05H in this case, and by this offset address we can access any element in that location inside our memory directly through our instruction, and thus we can store that value which is there inside this memory location inside our destination, which is CL in this case. So in this case, as we can see, the keyword is direct. Why? Because we are directly specifying the address of the operand directly in our instruction. So the fourth type of addressing mode is our indirect addressing mode. Now under the indirect addressing mode we have a few subcategories. The first one being the register indirect addressing mode. In this type of addressing mode, any of the two base registers, which are our BX and BP register, or any of the two index registers, which are our SI or DI registers, are used to provide the offset address of the data byte. So we know in our 8086 microprocessor, there are base registers which are called the BX and BP, and there are index registers which are called SI and DI. So any combination of these four registers are used in this type of addressing mode in order to provide the offset address. Now we got the offset address, so who will give the segment address now? We know the segment address is determined by the register we are using. For BX and SI, they point to the data segment in our memory. For BP register, it points to the stack segment in our memory, and for DI register, it points to the extra segment of our memory. So these three things are very important in order to understand what this type of addressing mode is. So we know in our memory there are 4 types of segments, among which these 3 segments come into the picture in this type of addressing mode. So let's take up an example. Suppose we have move CL, in brackets we have BX. So what does this mean is, this BX will point to the data segment. Here we can see BX points to the data segment. So BX will point to the data segment. The BX will have the offset address of a particular location in the data segment. Now the physical address is calculated as this DS, which is the data segment, into 10H plus the offset address which is given by the BX. Suppose in this physical address we have 06H stored inside the data segment. Now what this instruction will do is, it will move the value from this location into the CL register, just as this. So to summarize, so whatever is written within this bracket, which is BX, is a base register. This BX points to the data segment in our memory, and the physical address of any location inside this data segment will be calculated by DS into 10H plus BX. And suppose we have this 06 value in this physical address inside our data segment. So when we give this command move CL, in brackets BX, what this will do is move the value from BX offset address, which is this one, into our CL register. Let's take up another example. Suppose we have move in brackets we have BP, CL. Here we can see our destination is specified inside the brackets. So suppose inside our CL register we have a value 06H. Now since in brackets we have BP, so BP points to the stack segment. So the physical address of this stack segment will be calculated as SS into 10H plus the offset address which is given by BP. So whatever this location is inside this stack segment, suppose this one, here our data will get stored. So the value from CL will move to that location inside our stack segment since it is BP. Now this type of addressing mode might have different names in different books, but the main thing to notice here is the keyword, as I said in the previous slides. Here the keyword is register and indirect. Now register, as we can see, this BX, BP, these are registers, and indirect means they will be specified inside brackets. So here the keywords are register and indirect. So register as in base register or the index register, and indirect means in brackets they will be specified. So the next category that we have is our indexed addressing mode. So what happens in this is, in this type of addressing mode, any of the 2 index registers, which are the SI and DI, are used to provide the offset address of the operand. So we know we have 2 index registers in our 8086 microprocessor, which are the SI register and the DI register. And these 2 registers are used to provide the offset address of the operands inside our instruction. So just like the previous category, here we can see the segment address is determined by the register used. So here we are using the SI and DI registers. So SI will have the offset address inside the data segment, and the DI will have offset address inside the extra segment. So let's take up an example. Suppose we have move AX, in brackets we have SI. So we can see inside brackets we have an index register. So what this instruction will do is, this SI will provide the offset address inside this data segment, as we can see here, and the physical address of any location inside that data segment will be calculated as the data segment address into 10H plus SI. So this SI will give the offset address inside this data segment or within this data segment. Suppose in this physical address we have a value 06H. So what this will do is store the value 06H inside our AX register. So whatever value was there inside this location will get stored inside the destination register, which is our AX in this case. So let us take another example. Suppose we have the instruction move in brackets we have SI, comma CL. Now, since we have this index register SI, thus we know that this SI will provide the offset address within the data segment. So suppose if we have a value 06H stored in our CL register, so what this instruction will do is, this instruction will point to a particular address inside the data segment, whose physical address will be given by the data segment address into 10H plus the offset address which is provided by our SI register here. Suppose this location has the physical address of this. So what this instruction will do is store the value which is stored in our CL register, which is 06H, inside that location. Thus the key point to note here is, here we see the keyword is index. So we will have index registers which will be SI or DI, and they will be inside brackets because this comes under the indirect addressing mode. In other books it might have some different name, but look for the keywords which is index in this case. The keyword here is index. So whenever we see index inside our addressing mode name or index registers in our instruction, then we can say that this is some kind of index addressing mode. So the next type of addressing mode is base relative addressing mode. So what does this say? In this type of addressing mode, the offset address is calculated using one of the base registers and a 8-bit or 16-bit displacement. Now in one of my previous slides I discussed offset address has three elements, which were displacement, the other is the base, and the other part is the index. And I told that this offset address can be calculated by the combination of any of these three elements. So in this case, the base registers, so here the base, and the displacement, 8-bit or 16-bit displacement, which is this, will be combined to find the offset address of any particular location inside our memory. So let's see what that means. Suppose we have an instruction move CL, in brackets we have BX plus 6H. Here the BX is our base register and this 6H is a 8-bit value which is known as the displacement. Thus we can see our total offset address, which is this one, is calculated by combining the base address and a 8-bit value which is called the displacement. So instead of this 8-bit value, we can have any 16-bit value as well. And we know this base register BX points to the data segment. So the physical address will be given by data segment address into 10H plus BX plus this displacement, which is 6H. So let's take up a few values for this DS BX in order to understand the concept more clearly. Let's say the value of DS is given as 1000H and the value of BX is given as 1234H. So we can apply these two values inside this formula in order to calculate the physical address. So the physical address will be 1000H into 10H plus 1234H plus this displacement value. So the physical address we will get as 11240H. And this physical address will be inside our DS, that is data segment. So suppose we have a value 06H inside this location in the data segment. Why data segment? Because here we have BX which gives the offset address within our data segment. And we have calculated the final physical address. So in this address we have 06H value. So what this instruction will do is store whatever value is stored in this location, which is this location 06H, inside our CL register. So this 06H will get stored inside our CL register. So here again the keyword is base and relative. So the keywords are base and relative. Base means the BX or BP register and relative means the displacement. Thus, this type of addressing mode can have other names also, but the only common thing in those names will be these two keywords. So whenever we find these two keywords in our addressing mode, that is the base registers or a displacement value, then we should know this type of addressing mode works like this, and it is called the base relative addressing mode. So the next category we see is our base plus index addressing mode. So in our base plus index addressing mode, the offset address is calculated using one of the base registers, which are the BX or BP, plus the index register, which are the SI or DI. So previously we have seen the offset address was a combination of displacement, base, and index. So in this type of addressing mode, we are combining the base and the index in order to provide the offset address. So let's take up an example. Suppose we have move CX, in brackets we have BX plus SI. So as we can see, this BX is a base register and this SI is an index register. So base and index register. So now the physical address will be calculated as the DS into 10H plus BX, which is given by the BX register, and SI, which is given by the SI register. So these two are the offset address. So let's see with some values. Suppose the value of DS is 1000H, BX is 1234H, and SI is 1312H. So the physical address is calculated as 1000, which is the DS, into 10H plus the BX value, which is 1234H, plus the SI value, which is 1312H. So the physical address comes as 12546H. Now what this instruction does is, suppose our data segment has a value 06H inside this location. So what this instruction will do is store the value which is 06H inside our CX register. So CX register will now have the value 06H. So to summarize, in this type of addressing mode, for the offset address, we have both the base register and the index register, and the physical address is calculated, and similarly, just as before, the data from this physical address is stored in the destination register, which is CX in this case. So for this type of addressing mode, the main keywords is the base and the index. So whenever any addressing mode has these two names, the base and the index, then we should know the offset address, which is this one, should have the base register and the index register, and these two will provide the offset address. The next type of addressing mode is the base relative plus index addressing mode. So one thing we can observe from the name is it has the base, it has the relative, and it has the index. So we have seen offset address is a combination of any three, and in this type of addressing mode, all the three combination is used together. This base address will be given by the base registers, the relative will give the displacement, and the index will give the address from the index registers. Let's see in that in detail. So in this type of addressing mode, the offset address is calculated using one of the base registers, which is BX or BP, plus the index register, which is the SI or DI, plus 8-bit or 16-bit displacement. So let's see an example. Suppose we have move CX, in brackets we have BX plus SI plus 50H. So in this we can see this is our base register, this is our index register, and this is our displacement. And since this is a kind of indirect addressing mode, so it is written inside this brackets. So the physical address will be calculated as DS into 10H plus BX, which is given by the BX register, plus the offset address, which is given by the SI register, plus the displacement, which is 50H in this case. So let's take up some values. Suppose DS is equals to 1000H, BX equals to 1234H, SI equals to 1312H, and displacement is equals to 6H. So how the physical address will be calculated is 1000H into 10H plus this BX, which is 1234H, plus this SI, which is 1312H, plus the displacement, which is 6h. So the physical address will come as 12552h. So what does this instruction means is, suppose in data segment, in this physical address that we got from here, we have a value 1006h. This is a 16-bit value which is stored in this location. So what this instruction will do is take this value, which is 1006h, and store it in our CX register, just as the previous cases. Another example for this type of addressing mode can be move, inside brackets we have BP plus SI plus 1200H, comma CL. The only difference between this addressing mode and this addressing mode is, here the offset address is provided in our destination. So whatever value is stored inside this CL register, it will get stored in this address. So the final addressing mode I want to speak about in this video is the implied addressing mode. This is another category which does not fall under the indirect category. Till the last addressing mode, we saw the various subcategories of the indirect addressing mode. Now in this implied addressing mode, the operands are implied. That is, the operands are specified implicitly in the instruction. For example, this CLC instruction, which is basically used to clear the carry flag. So whatever value is stored in our carry flag, it clears the value of that. Thus we can see in this instruction there is no operands which are implicitly written inside this instruction. Thus this is a kind of implied addressing mode. Other examples for this can be the STC, which sets the carry flag, or the CLD, which clears the direction flag. So with this I have almost discussed about all the important addressing modes that we use in our 8086 microprocessor. Few addressing modes which are left I will be discussing in my next video. So if you like the video, please like, share and subscribe to my channel. And if you want the slides, then you can go and visit my Instagram profile. Link will be in the description. So thank you and happy learning.